Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. I hope you all are doing good. Our lectures were a bit delayed because I was not well, as I informed you. Now we are going to study logarithms in this lecture, and this is a very important chapter in CA Foundation, CPT, CAT, SSC, and almost all competitive exams. Okay, this is also important for 12th board students because log is a very big difficulty while doing differentiation, because understanding log is very important. Okay, so we are going to learn logarithms, and for logarithms you need to learn about exponential form, exponents. So exponential form and logarithmic form are two forms you have to understand. Exponential form and logarithmic form. Exponential form, 2 raised to the power 3 is equal to 8. Now, if the question is asked in the reverse manner, that what power we'll raise 2 that it gives 8. So the answer is 3. To what power we raise 2 so that it gives 8? The answer is 3. So in exponential form, the base was 2. In logarithmic form, the base is 2. But the notion is very different. Okay, for example, 4 square is 16. So 4 is written in this size, and this is the superscript that is written in smaller size. Okay, so base is written in larger size, and the power is written in smaller size. Okay, in logarithmic form, base is written in smaller size. Base is written in smaller size. The value, the output in exponential form becomes input in logarithmic form, that is 16. It is written in larger size, and the answer is 2. That was input in exponential form and becomes output in logarithmic form. That is also written in larger size, but base is written in smaller size. Okay, so in both these forms, this 4, which is the base, uh, is neither input nor output. Okay, 4 is neither input nor output, it is base. But this 2 and 16, this 2 and 16 in exponential form, 2 was input, 16 was output. In logarithmic form, it is just reverse, 16 was input, 2 was output. So as compared to all other functions, like square function, modulus function, sine, cosine, and all, there are three things in logarithms. For example, when we talk about x square, we put 4 and we get 16. So there are two numbers at a time. Okay. When we talk about x square, we put 5 and we get 25. So two numbers at a time. But when we talk about log, we have three things: input, output, and base. Okay. When we talk about log, we have three things: input, output, and base. Because base is also very important. Without knowing the base, we can't say anything about log or values. Okay, so in exponential form, we write 10 raised to the power minus 1. 10 raised to the power minus 1 is equal to 1 by 10, that is 0.1. So in logarithmic form, at first we'll write base. The base is 10. We write it in smaller size, and at a significant distance, we write 0.1 here in normal size, or we can say larger size, and we get the answer as minus 1. Okay, a few things we have to keep in mind. There are a few restrictions in log. that when we talk about log b to the base a or log a to the base b, neither this a nor this b can be negative. Okay, that means the input and base, the input and base cannot be negative in log. The input and base cannot be negative in log. Okay, I hope you are getting my point. The output can be negative like this. Sorry, like this, the output can be negative, but the input or base, neither of them can be negative. Okay, also both of these must be greater than 0. That means these can't even be 0. Okay, these can't be negative, can't be 0. And there is an additional condition for base. The base can't be 1. The base can't be 1. So when we talk about restrictions with log x base b is equal to a, in that case x greater than 0, b greater than 0, b cannot be equal to 1. A can be anything, a can be any real number, but x and b both must be positive. X and b both must be positive, and b must not be 1. B must not be 1. That means you can't put the base of log as 1. Okay, now after restriction we'll learn two different types of log that are very well known. Log a base 10, and next is log a base e. This is just an introduction because this lecture is for all stream students. So this topic I am just introducing this one, not describing. Okay, because this lecture is meant for all course students, so the I am just describing this for now, just introducing this for now, not describing. In further lectures we will specially mention about natural log, that is so this one is called common log and this is natural log or Nappierian log. Okay, this is also written as ln a. Okay, so common log, what is common of for the sake of simplicity, when we don't want to write base, we simply write log a. If the given question is not concerned, it is not about calculus. Okay, if the given question is not related to calculus, then the base is by default 10. Okay, then the base is by default 10. Calculus means functions, relations, differentiation, integration, maxima, minima, these things. Okay, so when the given question is not related to calculus, the base is by default 10 and it is called common log. Base is not given. When the base is not given, and the question is not related to calculus, when the base is not given and the question is not related to calculus, the base is by default 10. And when the base is not given and the question is related to calculus, base is not given but the question is related to calculus, then the base is e. E is an irrational number that is approximately equal to 2.718, because we can never write the exact value of an irrational number practically. Okay, E is an irrational number whose approximate value is 2.718 and it is the base of natural log. Okay, and E is defined as e raised to the power x is equal to 1 plus x by 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial plus so on. When we put 1 in place of x, then we get the value of e, because e raised to the power 1 is equal to e, that is 1 plus 1 by 1 factorial plus 1 square by 2 factorial plus 1 cube by 3 factorial plus so on. That comes out to be approximately 2.718. Okay. And if you don't know about factorials, that we will study in permutations and combinations, but I am just describing it for now. That if you are given with 5 factorial, that means start with 5 and go up to 1, 5, 4, 3, 2, 1. If you are given with 7 factorial, then start with 7 and go up to 1, 7, 6, 5, 4, 3, 2, 1. If you are given with 0, then 0 factorial is by default defined as 1, 1 factorial is 1, and thereafter 2 factorial means 2 into 1, 3 factorial means 3 into 2 into 1. There is no factorial of negatives or decimals. The factorial is not defined for negatives or decimals. Okay, factorial is not defined for negatives or decimals. So I told you about factorials also, so you can also try to evaluate this and check yourself that it is 2.718 or not. Okay. Now common log, I told you, if the base is not written and the question is not about calculus, then the base is by default 10 and it is called common log. If the question was about calculus and the base was not written, then the base is e and it is called natural log. And there is a third style of writing it also, ln a. Ln means the base is e. Ln means there is log but the base is e. This is the more sophisticated way of writing natural log. Okay. Common log and natural log. Restrictions with log, I told you. Logarithms, exponential form and logarithmic form. Let us see a few more things. Minus 2 raised to the power 2 is equal to 4. It can't be written in logarithmic form. Why? Because when we start writing this, then minus 2 is there in base, so this cannot be written in logarithmic form, because the base will be negative and the base negative is not allowed. Okay. 1 raised to the power 5 is equal to 1 log base 1 is equal to 5. No, it is not possible, because we have given base 1 here, which is not allowed because base can't be 1. Okay, because 1 raised to the power 6 will also be 1, 1 raised to the power 7 will also be 1. So how can we be sure about the answer that it will be 5 only? It can be 6 also, 7 also. Okay, that's why because logarithm is a function, it has to give a unique value. I also taught you functions in previous lectures. Just a few lectures ago, 2 or 3 lectures ago, I told you about functions, and I told you that if you put an input in a function, then you get a unique output, not 2 or 3 or 4 outputs. So when you write log 1 base 1, then you can get 1 or 2 or 3 or 4 or 5. There are infinite possible values which satisfy this. So if you are getting more than one output, it won't be a function at all, because it will violate the definition of the function. So the restriction is put there that 1 cannot be the base of a log. Okay. Negatives and zeros are not allowed in input or base, and 1 also cannot be the base of a log. 1 can be input, but 1 cannot be the base. Okay. 5 raised to the power 0 is equal to 1, so log base 5, the input becomes output and output becomes input. So input is 1, the answer is 0. Yes, it is perfectly fine. Ask this question to yourself: to what power we raise 5 so that we get 1? 5 raised to the power what? 5 raised to the power what is equal to 1? Sorry. 5 raised to the power what is equal to 1? The answer you will get is 0. So this is the funda of log. Okay, now we'll see a few questions. Log 0.001 base 10 is equal to what? Let us say it is equal to x. When you don't know about how to evaluate a given logarithm question, then you just convert. Why convert, sir? Because you don't know log, but you know exponents, you know indices. Okay, so if you convert, the question is no longer of logarithms chapter, it becomes of indices chapter. Okay, when you convert, remember this arrow, 10 of this size, the power of this size, the answer of this size. Okay, 10 raised to the power x is 0.001, or you can also go with the trick I told you, that to what power, we raise 10 that we get 0.001. The same thing is written here. See, okay, so now it seems very easy, because 10 raised to the power x is equal to 1 by 1000. 10 raised to the power x is equal to 1 by 10 raised to the power 3. 10 raised to the power x is equal to 10 raised to the power minus 3, because when we take this upside, then the power becomes negative. X is equal to minus 3. Okay, so this is our answer. To what power we raise 10 so that we get 0.001? The answer is minus 3. The base is not negative, not 0. The input is not negative, not 0. The base is not 1. The answer can be anything, and the answer is minus 3 here. Okay, this is how log works, but let us see a few more things. For example, 243 is here and here is 3. You know that 3 raised to the power 5 is 243, because 3, 9, 27, 81, 243. If you like math, then it would be your hobby to determine powers and go higher and higher, 6561 and so on. But if the scenario is changed, log 81, 343, what to do? You know it is 3 raised to the power 4, and you also know it is 3 raised to the power 5. When these two things become common, then do you know what do you have to do? You have to just write it 4 by 5. Yes, as simple as that. As simple as that. Take 4 from here and 5 from here, and 4 by 5 is your answer. Log 32 base 16 is equal to log 2 raised to the power 5 and 2 raised to the power 4. Okay, it is 5 by 4. Now a very interesting question, how do you pronounce it? Log 243 base 729, how do you pronounce it? And I am extremely sorry for this silly mistake. This is not 343, this is 243. Sorry, this is 243. Okay, by mistake I wrote 343 there. 343 is not 3 raised to the power 3, power 5. That was a writing error, human error. Okay, log 243 and there is 729. How do you pronounce it? Many of you pronounce it incorrectly. Okay, many of you don't know how to pronounce it. Many of you say log 729 raised to the power 243. Many of you say log 729 243. No, this is not the proper appropriate way to pronounce it. You have to say log 243 to the base 729, or for the sake of simplicity you can say log 243 base 729. Okay, log 243, log is the function, this is the input. So these two will go hand in hand. And the additional information which is required is the base. You have to tell the base in the end. Okay, for example, you say sine 30 degree. 30 degree is the input, sine is the function. 30 degree is the input, sine is the function. So you always say sine then 30. In the same way, you say log then 243 because 243 is the input and log is the function. 729 is an additional information. 729 is the base. So you say in the end that base 729. Okay. You say log 243 to the base 3. Log 81 to the base 243. Log 32 to the base 16. Okay. This is how it works. Now we learn laws of logarithms. And I will also remind you laws of indices. Okay. Ten raised to the power what is 50? You'll say, sir, I don't know exactly. 10 raised to the power what is 20? That also you don't know. You'll need either a scientific calculator or you'll need a table. But this plus sign and these common powers, these will help you to find out the value. There's a law, log m plus log n. I'm not writing the base for the sake of simplicity. I'm not writing the base for the sake of simplicity. That means if the base is common, if the base is same, then this law, log m plus log n is equal to log m into n with the same base, which was here, and that the same base will also be here. Okay. Log m plus log n is equal to log m into n. Log m minus log n will be equal to log m by n, and the base will be here, the same base which was in these two. The laws are applicable only when the base is common, the base is same. Okay, so how can we evaluate this? Log m plus log n, that is equal to log m into n, that means 15 to 20 thousand. 1000, the base is same, the base will be 10. 10 raised to the power what is 1000? 3. 10 raised to the power 3 is 1000. You know that, you already know that 10 raised to the power 3 is 1000. So the answer is 3. Okay. Next, log m raised to the power n. The power jumps here and it becomes n into log m. The base which was here will remain here. Okay. And let me remind you the laws of indices. A raised to the power m plus n is equal to a raised to the power m into a raised to the power n. A raised to the power m minus n is equal to a raised to the power m divided by a raised to the power n. A raised to the power m to the power n is equal to a raised to the power m into n. Okay. Laws of logarithms, laws of indices. These have things in common because obviously you have seen that indices are related to logarithms. Exponential form is the reciprocal of logarithmic form. Okay. So this was the basic idea of logs. I will expect that all of you take a look at your respective courses, and if some material you are following given by your own course institute or body, or you are following our material, okay, you take a look at the questions and the pattern and the syllabus, and then you wait for the next lecture, because in the next lecture we'll do problems of logarithms. This was the introduction of logarithms. Please don't forget to tell us in the feedback if you liked the lecture or not, and ask doubts on 8294600829 WhatsApp. Please only WhatsApp on this number, don't call. Don't call at all, okay? Not even WhatsApp call. And don't forget to like, share, subscribe. Thank you so much. Happy learning. Bye bye.